Good morning, good afternoon, and good evening. It's the Oracle of Chinemkutu, and welcome back. Today we have got a question that was sent by a grade 12 student, and it had three questions. We are going to look at question 1, which has got two parts, question 1.1 and question 1.2. And the first question says, determine f prime x from first principles if fx is equal to 3x minus x squared. F prime x is actually find the derivative of this function, but using the first principles. This is a question that is given to students at matric level, students at AS level, and also students at advanced level. From O level probably to further maths, advanced maths, O level, you are still asked questions where they want to see you apply concepts that you have learned. Once you start going beyond O level, they start asking you to derive the concepts themselves. In other words, you will be required to know how a particular concept or a particular formula is derived. In other words, you should do proofs, or you should do steps that shows that you understand where a concept is coming from. In that way, once you are given a problem that you cannot immediately or directly apply a formula on, you can actually derive your own solution through first principles. So here they are asking you to determine the f prime of x from first principles, given that if fx is equal to 3x minus x squared. We are going to name the first part of this question the application of calculus 5, differentiation, first principles, part 1. We are going to do these questions in 2 separate videos because this is quite involving. I will try and explain to you so that you understand how you apply first principles to get the derivative of that function. As you can see, this function is basically a quadratic function. It's a minus x squared, so it is concave down. And we can say question 1.1, and basically we can draw our function as that, and we call this function 3x minus x squared. Let us call it fx is equal to 3x minus x squared. So we want to find f prime x. We define two points anywhere on the function let them B, P, and Q. So basically what we can do is we can say there is P and the coordinates of P are x and the f of x, and then we can say q, and the coordinates of q are x plus delta x and f of x plus delta x. So basically, we want to find the gradient there. So we start with that line there, and as we move it out to get to the point of tangency, where that line becomes a tangent to the curve, we will then find the gradient to the curve at that point using that tangent. So f prime x will give us the function that defines the gradient of the curve at any point, and for you to get the real value of that gradient, you have to substitute the value of x at that point. So, having said that, we know that gradient is given by delta x, delta y over delta x. So, given this equation, we know that delta y is equal to, we substitute that value of x into the function there, which would be 3 bracket, our value of x there is x plus delta x minus x squared. You can say bracket x plus delta x squared. And so we subtract the original function from this here, so we can get the value of delta y. So we say minus, put square brackets there, we take there, and we are taking that point P there. So we say minus 3x minus x squared. So this is, you can call that your equation 1. So when we refer to it in the future, we will know what we are talking about when we say equation 1. So basically what we have done here is to say that the change in the fx or the y value is the x coordinate of q substituted into the value of x of our function minus the x coordinate of p substituted into the x value of our function, and that difference gives us the delta y. We will get to a stage where we will introduce the delta x so that we get our gradient, but for now let us simplify this. This is then delta y equals to 3x plus 3 delta x minus bracket, we square that, that would give us x squared, x times delta x times 2 would give us 2x delta x plus delta x squared minus, we can remove the square brackets there, and this becomes 3x plus x squared. When you are removing the brackets, you multiply everything that is inside the bracket by minus 1. So then we have delta y equals to 3x plus 3 delta x minus x squared minus 2x delta x minus delta x squared minus 3x plus x squared. And again, when we removed the brackets there, we multiplied everything that is inside the bracket by minus 1. This would give you minus x squared minus 2x delta x minus delta x squared minus 3x. And you can see that a 3x minus 3x, a minus x plus x, a minus x squared plus an x squared, these would actually cancel each other out. So once they cancel each other out, we have delta y equals to 3 delta x minus 2x delta x minus delta x all squared. So we can then say delta y is equal to, we can actually take delta x out. So we have 3 minus 2x minus delta x, and because delta x is not 0, we are going to divide throughout by delta x. Divide throughout by delta x, since delta x is not 0. And basically the reason why we are dividing by delta x is so that we end up with delta y over delta x, which is the expression for our gradient. So therefore we say delta y over delta x is equal to delta x bracket 3 minus 2x minus delta x bracket over delta x. And since delta x is not 0, we can cancel out. So this delta x cancels out with that delta x, and we can say this is equal to 3 minus 2x minus delta x. And as the delta x goes to 0, delta y over delta x goes to dy dx, and therefore dy dx equals to 3 minus 2x minus delta x, which is the limit as delta x goes to 0, so that delta x goes to 0, and therefore dy dx is equal to f prime x is equal to 3 minus 2x, and that is your final solution. And in other words, we have just found the derivative of 3x minus x squared, but using the first principles. So here what they are testing you is your understanding of what is happening for you to get the derivative using first principles. Don't be perturbed by the complexity of the function. Any function that they give you, you can use this same method to get its derivative. So this is how you do it, differentiation in first principles. Please like and comment on the video, and if you have got any questions, you can send those questions directly to my WhatsApp platform, +27 81 4411 390, and let us communicate. Thank you.